Hi. Is this on? Can you hear me? Last row? Cool. Okay, so welcome. This talk is about how we at SoundCloud work together as a company, as an engineering organization, how we deploy hundreds of microservices without a dedicated operations team. So this is really what the core of this is, how we deliberately got to a place where we don't need an operations team anymore, and how we got there and why we did it. Brief intro about SoundCloud and myself. SoundCloud is, well, a cloud full of sounds. It's kind of in the name. It's a music and general audio service, both for user-generated content as well as for professional music. We have about 135 million tracks by 12 million active artists and 175 million active listeners. We are over 300 employees and we don't have an ops team. I am personally on the production engineering team. The reason I'm standing here today is because I was part of the remnant of the original ops team. At the time that I joined it, it was already called systems engineering, and I was part of driving the push to get it shut down and to get rid of this old also on-call rotation. So I pushed the button that said no more ops. So this is what I'm going to talk about today. I'm going to briefly go over where we came from as an engineering organization, where we started out, how we work today. I'm going to describe that. I'm going to describe why we went down this route, what didn't work for us in the previous model, and what is working better for us now. And I'm trying to wrap it up. I'm trying to give you some tips to how you can do this for your organization. So where did we come from? This is a short history of engineering at SoundCloud. There are other talks and blog posts about the longer versions of this. So if you want to know more, come talk to me after the talk. So SoundCloud started out as a single Rails monolith application. Like so many services of its time, this is what you did back then. You Rails generate and then you start hacking on it. That worked great. Initially, there was like a tiny team of people working really closely and constantly deploying. We had, after a while, this turned into the app team, which took care of this app versus like a front-end team, and the app team would do the deploys. And we had an ops team. The ops team was originally brought in when we moved from managed hosting into our own data center to help with that. One thing that the ops team never did was deploy the app. The app has always been deployed by the app developers, even when they weren't on call for it, which led to some pain in that, for example, they would deploy something on like Thursday afternoon or even on Friday around noon. And we are based in Berlin. Our main user base is in the US, so about 6 to 8 hours behind. Our peak load time is just when everyone in Berlin has gone home, and then it was left to the ops team to sort out what's going on now, what did we break this time, where is the performance regression. We had to page in app developers all the time to help with that. So that didn't work very well. Also, deployments became more and more painful. Not so much the act of doing the deploy, but the risk associated with them. It often caused issues to deploy, so we deployed less frequently, which means when it caused issues, it was no longer clear what's causing the issues. We had to, if you deploy 15 changes at the same time and something goes wrong, well, first you roll back and then you leave, and then you scratch your head and try to guess which of these 15 changes it was. So yeah, this couldn't go on. This didn't work anymore. It was also, this app team became a bottleneck, and they became, a lot of the times feature work had to wait, and like front end work had to wait several weeks for them to get to doing the back end work. So that didn't work. We pulled what these days is called an inverse Conway maneuver. Who doesn't know what that is? Okay, there's a few people. So there is this thing called Conway's law that says that when an organization, like paraphrased and butchered by me, that says when an organization builds software systems, the systems mirror the structures of the organization. An inverse Conway is when you use this to your advantage and you build the organization to match the systems that you want to have. So we wanted to pull apart the monolith, but that's really hard and it takes a really long time. So what we did first was we pulled apart the app team and we split it up. In the end, we also started building smaller services for specific functionality. In our case, and in many cases that I've heard of, the first were search and payments. It kind of tends to be natural that you start breaking out those two. And then at that point, we had like 3 or 4 services that made up production, and it became very tedious for us to act like the deploy process became an issue. But at that time, we deployed using Chef and Capistrano, so you would like cap live deploy, and then it would SSH to a bunch of machines, and they would clone a repository and then run a bunch of commands. And building new machines was an arduous process, which, because the ops team didn't know how to deploy, they couldn't actually do. When I joined systems engineering, we didn't know how to deploy the mothership, the monolith. Whenever we built it, we had to like bring the machine to the state where it could take the code, then tell the app developers, can you please deploy so they have the code, and then we could go back and actually put them into load balancing. It was horrible. I learned to deploy just because of that, but this would not have scaled to many services. This was not a feasible process. This was about 2012. So Kubernetes and even Docker wasn't a thing back then, but we built our own deployment platform. It was loosely styled after Heroku, so you would do a git push, and then it runs some magic for you, and then you can scale up your application. It wasn't great. We've since moved off it. We finally turned it off this year. And we moved to Kubernetes instead. But the gist is the same. We had a platform that made it really easy for developers to get their code into production. Everything else was kind of secondary to that. It had to be easy for developers to get their code into production. We started forming on-call rotations per team. We sometimes went too far and had on-call rotations like for one specific individual service with like 2 people on the rotation who would vary between primary and secondary. Don't do that, it's bad. It burns out people very fast. We didn't properly pay attention to this initially. We later rolled that back somewhat, and we're now consolidating these rotations a lot more. So today, we have what we call feature teams. A team conceptually owns a feature from end to end. A team owns, say, the stream. So we have the stream of like everything that everyone posted, who you follow. That is kind of a complex feature to build. It lives in its own ecosystem of microservices. And there is a team that owns this from the application code in your mobile app to the storage backend that holds what is in your stream. And it's kind of up to them how they do this. Obviously, we want to avoid having them having to reinvent the wheel every time. So we have what I call shared components that make it easier, that they can use and just plug in and say, okay, database is sorted now. The deployments are largely automated and continuous and extremely frequent. We deploy almost every change. And we usually deploy them like on the same day that we make them, they pass the tests, and some services just go straight to production, no human intervention required. Some have a little button that says deploy now, and so someone says, oh, I'm back from lunch, deploy now. And then, oh, I'm gonna go home in an hour, deploy now. Which makes it much, much easier to deploy now, because you're deploying one change at a time. And if it's easy to roll back, so if it causes a problem, you roll back. If it causes a problem at night, you roll back, whatever. You're rolling back one change. You know what changed. You know the safe state of the system before, and you have a very narrow search focus for where the problem could be. This is a huge difference to the 15 changes we use to deploy at the same time that would then weirdly interact. So this is where we are today. We are largely organized in feature verticals. These are roughly grouped into clusters like listener features, everything that goes into your experience when you're just listening to music on SoundCloud is one cluster, including the stream. We have a separate cluster for creator features. We have one cluster for like monetization and actually making money off this. This is kind of the size of these clusters. Before we got to that, we went too far with our feature teams. They were too narrow, and we ended up with isolated, say, an iOS developer on one of these teams without contact to any other iOS developers, and no one to share code reviews with. So we kind of reconsolidated this into these larger clusters, so that within the cluster there is a healthy exchange. At less than 200 engineers, we realized that we could not afford to have 30 engineering teams. That didn't work out. On the basis, we have what we call core and infrastructure. These are the teams that provide all the things that are needed by the feature teams, by the product development teams to be able to do their work. That includes running the deployment platform for them. That includes running a Hadoop cluster so they can do all their big data. That does not include writing the queries for them, and it also does not include, for example, running the databases for them. Each service, each system, whether it's an internal infrastructure system or whether it's a system that provides part of some functionality, has an owner. This is the most important bit. This is the bit that we kind of never really lost. We sometimes lost track of the ownership of individual pieces, but we've always had this concept of everything has someone who owns it. And these days, we're pretty strict about this. If we find something that doesn't have a proper owner, because it was forgotten when the team that owned it got disbanded or like changed focus, we go to management and we say, find us an owner for this. And they go and they find an owner for this. The new owner may not like it. There are some services that nobody wants to own, but somebody has to own everything. Because there is no default ownership. Before this, it used to be that we have this ops team that would just take on whatever falls through the cracks, it falls onto the ops team. Oh, this has no owner, I guess ops is on call for it now. Ops has never seen this thing before, ops doesn't know what this is, so that didn't go well. Now we have this thing, every team has an owner, and there is a clear handover. If one team takes on a bunch of systems from another team, they go and say, actually, are these even in a shape that we're willing to take them in? And then that team puts them into shape and then hands them over. That includes documentation as well. Sometimes ownership does overlap. For example, I said the code in the mobile application that renders your stream is owned by the team that owns the stream, but the whole app is not. the whole app is a shared code base owned by many people. In that case, each team that owns a particular feature owns the code that is directly responsible for this feature. But there is also a core clients team that owns the integration, that owns the code base as a whole, that takes care that all these features play together and chase down the owners of the features if they don't, that actually manages the release process of this. So this is where sometimes the ownership is on a sub-code base level. And this is also important, everything is owned by a team. Nothing is owned by individuals, not even hacker time projects. We have this concept called self-allocated time, where basically 1 day a week, you can take a break from your backlog work and you do something that you and your team find valuable but would not normally get done. That, even though it's done by an individual, it is always sanctioned and owned by the team. And if that individual changes team, per se, these projects do not change team automatically. They could be handed over, but they're not necessary. This avoids things getting lost when people leave or change teams. It's just very clear. It's still not foolproof. Teams also disband and change, but it's much less common for a team to just disappear than for an individual to hand in their resignation and be gone. Or to be sick. Teams don't get sick as such. So over time, and this is mostly what this talk is about, our definition of ownership has expanded from you own the code and the deployment to you own the code, the deployment, the associated infrastructure like databases, and the support for it, so OnCall. This expanded definition directly implies that owners are on call for everything that they own. So almost all our developers, or many of our developers, I think about half, are on one on-call rotation or another. We got too far into this and almost everyone was on call all the time, and that was not good, that was really unhealthy. So we set out to fix that, and we had groups of teams. First, within each team, they would say, okay, what are we all on call for? And they would consolidate that into one rotation for the team, and then subsequently multiple teams found together and said, okay, our services are structurally similar enough and they work together closely enough that it makes sense for us to just have a shared first level on-call. The expectation of the first level on-call is not to be able to fix any problem in every system. The expectation is that they can read the runbook and apply common, like they can triage and do common resolutions to problems. If that doesn't work, they can still escalate to the people who know the system better. And to make this feasible, we removed a lot of alerting. We had a lot of super noisy alerts that would wake you up twice a night for no good reason at all. Just delete them, delete all of those. If you get woken up by an alert and it doesn't make any sense and you get woken up by it and you know that this is okay, then delete it the next morning. You don't have to delete it at night, but delete it the next morning. You will not miss it. We had a lot of alerts that we had to think real hard about it, and then we deleted them. Also, to make this possible, especially to make the consolidation possible, we had to write a lot of documentation. And it turns out we did. It's like, people always think that it's super hard to get developers to want to write documentation. It's actually really easy, because if the application developers write good documentation for their code so that the on-call can solve the problems without being an expert in the system, they don't get woken up. If they don't, they get woken up. And they have so this is an incentive for the owners, the experts in the system, to write really good documentation, because everything that they document means they will get woken up less. So we write a lot of this documentation in the form of runbooks. So this is kind of what the system is. If you get this alert, it means that. This action usually helps. If it doesn't, try that other thing. And if it still doesn't, page the experts. So the combined effect of cleaning up alerts, of good documentation, and of this combining this large enough group of first level on-call means that the individual workload for being on call is extremely low. I have gone full weeks of on-call without ever getting paged. And when I do get paged, I can usually make out the problem, triage it, fix it in a relatively short period of time. And it is in my interest to keep it that way. So let's talk about shared components. One problem and one thing that systems engineering was on call for until the end was shared infrastructure. For example, we had databases shared between many teams, and that would cause a lot of issues because it's very easy to misuse a database such that they are so that they break for everyone who's using them. We split up all these into individual clusters, either by team or even better by system, so that each system has its own isolated database cluster. And this took a long time because we had to write a lot of documentation to make that doable. We handed off on-call for all our databases to the individual product engineers. Now, not everyone is a DBA. That's okay. Again, if you write a good runbook, you don't need to be a DBA to debug the issues that happen in a database in the middle of the night. Typically, the hard problems we've had with databases happened during the day when we deploy a change. In the middle of the night, it's more like a server died. What do I do? You can easily write a runbook for that you don't need a DBA to deal with. One anecdote, one of the last MySQL clusters that I was on call for. One day, I'm working away, I get paged for it. Slave lag. So MySQL has asynchronous replication where if you apply a very large transaction, it will take a while for that to propagate. I look at this and I'm like, I find out what the statement is that happened, and then I go over to the development team and I yell at them because they got me paged. They were running an alter table on a large table that just takes 20 minutes to complete. And they're like, yeah, but we know this is okay. We don't care about this slave lag. We don't want to, what is this? And I said, okay, so do you want to be on call for this? Because if you are on call for this, you can do whatever you want. You can migrate your tables any time of the day because you know what this is going to do and you are okay with it. You just can't do it while I'm on call for this. The next day, that team was on call for their databases. So this is a huge, these teams want to be on call for everything that they depend on because it makes them autonomous. It makes it much easier for them to move forward and to build a new feature because they don't have to wait for the schema change to go through some complicated process and be approved and then be applied by a DBA. We push that down to the teams. They are responsible for it. Sometimes they break it. That's okay. If they need, they have help. It's not like we don't have the experts anymore. We have fewer of them. We also, to make this easier for them, we also recently added proactive monitoring that will tell the owners of these shared components if they are about to run into a problem. Say you are close to get to capacity, you may want to do something about this. Because they don't know, they need to be notified about this. And a lot of this is automatable. It's totally automatable, so automate what you can. So MySQL is one example of a shared component that I already mentioned. Other components are memcached for caching. Prometheus for monitoring, Cassandra as a second database choice, and some common software frameworks. In all of these cases, it is optional for the teams to use them, but it is the easiest choice for them to use them because the tooling already exists and the setup already exists. They can just take it and say, I need this, and apply it to their system, and then they're basically done. If a team wanted to run Redis at SoundCloud, sure, they could. But is it worth it for them? Probably not. They're probably going to go with something like MySQL or Cassandra because it's already there. Unless they have a really, really good reason to use Redis, in which case nobody is stopping them. It's part of their autonomy is to be able to make these choices. So we have a really good balance there between commonalities and not duplicating work, but also having the flexibility to go beyond the technologies that we're already using and explore the new ones. So let's talk about the why. And what side effects this has on you and on your application or on your organization. So the biggest benefit that we've seen and the main reason we did this is for delivery. We want to deliver features faster, more nimbly. We don't want a large planning overhead of coordinating between many teams to get the feature spec'd and designed, and then the database changes done, and then the code changes done, and then the database changes and the code changes again. It's all in one team. They all sit on one desk and they can coordinate with this. This has taken down the lead time for this from weeks, multiple weeks, sometimes months, to, if they really want to, within 2 weeks or within a week, depending on the feature. Some features are faster, of course. It's also more predictable. For a product manager, it's much easier to plan the time that it needs within one team to do a certain amount of work, rather than planning for this team to do the work and then for another team and getting that team to do the work and then getting it back and waiting, and then autonomy helps with predictability, and in the end you just get more things done. You get more stuff out the front door. You also remove some hiring bottlenecks in this. Like you are no longer bound to how many DBAs or ops people you can hire, to a degree. It's great for personal growth. I say this as an engineer in this organization. This is a really, really good environment to work in, because you're not just doing your job, you're doing a variety of jobs. And you can learn something new every day. We don't have pure specialists. We also don't have, or people tend to specialize in some area more than another, but you always have some overlap. You're always a little involved with databases. Some teams have people who primarily deal with the database stuff, but everyone on the team needs to know enough about it to be able to work with it and to be able to debug it when something happens at night. Which, when you want to do something other than what you've specialized in so far, becomes extremely valuable because you already have the seeds of new knowledge, of new topics that you already know about, that you can just expand your knowledge into. We use this a lot. We use this as an organization and we use this as individuals by moving internally. It is very common for engineers at SoundCloud to move between different roles, to move from front end into back end, into infrastructure. We have people who joined as pure front end CSS and JavaScript engineers, took a liking to back end work, and now they're a security engineer because that took their fancy, so they're now a security engineer and they're good at it. So it avoids, as an engineer in this organization, you avoid being pigeonholed into just this one role. It opens up many avenues of personal development. And it's kind of also expected that as you become a senior engineer in this organization, that you broaden your horizon. You cannot afford to be just a front-end engineer. And when these people switch teams, say a front-end engineer moves into the back-end, or say a back-end engineer moves into the front-end, their new teams also gain valuable expertise. Because of what they've done before, they know a lot of things that that others on the team may not have, because a team of back-end engineers really doesn't know how to build a web interface. Suddenly, even though they're now more interested in back-end engineering, they have someone on the team who can teach the rest of the team how to do a front-end. So this is great. Like this goes all ways. Finally, you not only have better people, you also build better systems. Having these feature teams with many people interacting with some component of it who are not extremely familiar with it, and knowing that they are going to be the ones who need to deal with it, it forces you to build, and it encourages teams to build simple, straightforward systems. We use Scala a lot, and there are super complex ways you can write Scala code that nobody can ever understand except the people who wrote it, or like this particular flavor of Scala developer. We did all of that out. We write super simple Scala now that anyone can read, because it makes the teams more productive to do so. The same goes for the systems design in itself. Remember, if the first level on-call cannot handle it, they will wake you up. And they will make you think about, why did you build it so complex that I had to wake you up? We build them to be resilient. The development teams, being the ones who also deal with unexpected incidents, puts a natural stopper into how much feature work you can do that impacts stability. And this is a trade-off. I mean, you can build features in a very stable manner, and there are many practices that you can apply to be both, like to build new features quickly and stably, but at some point there is a trade-off. And if you have a separate development team and then they throw it over the wall to the ops team, and the ops team has to deal with it, and then has to come back to beg for time to deal with the bugs that are wrecking the databases, that's a horrible situation for everyone, especially for the ops engineers, because they have no way to actually fix this problem. Unless they go learn the database, at which point they become product engineers. So in this way, a team doing both the operations and the development of their service puts it onto the team, and it gives the team the flexibility to choose where they want to put the balance. It puts the payoff of tech debt where it occurs, which on the other hand means we don't need to have a strict rule against tech debt. We can, for the sake of features, for the sake of delivery, sometimes temporarily sacrifice some stability or some operability of our system. We know that we do this, and it's on to the team that does it to deal with it. They can deal with it by doing more, by having more operational overhead. Eventually, that means they will not deliver any new features. That is not what feature teams want, so they have a natural incentive to keep it at a manageable level. They are also not incentivized to work it off completely. There's always some tech debt somewhere. This is how we make progress. But it's there where it occurred, and it's there where it's accounted for. So this gives teams a lot of flexibility, also to deliver features when needed ahead of time. So and that also makes it so that teams build operable systems, because if they are not, they're going to spend all their time operating on them. And they're not going to get more headcount for it. So, okay, that's why we did it. Now, to recap, I want to backtrack a bit and lay out what you can do to make your engineering organization happier and more productive. So to get started, you need a little bit of automation. As I said, our deployment didn't take us very far. These days, you can get started with something like Kubernetes or DCOS pretty easily. So there is really no reason not to. But really, any kind of automation that you have and that you can have is better than not having it. For example, we have shared components. We don't have fancy web UIs where you can click to create database cluster. It's still, our database provisioning is super basic. We have a shell script that templates a bunch of roles into our Chef repository, and then you make a pull request, and someone says, yup, looks good, and then you merge it, and then you provision a bunch of servers. It's not magic. Right? It's still, and that's okay. We're all engineers. We're okay with dealing with text files. And writing it, and like editing a text file to get something done is fine as long as this is documented. So potentially document the automation that you already have, and that's all you need to get started. If you have any monitoring at all, which you should, you can always configure it to send different alerts to different people. So start by thinking about when this thing goes wrong, who should actually be paged for it. Put these people in rotations. You can use services like PagerDuty or OpsGenie or any of the others to organize these rotations. So this is something that you can easily outsource for a reasonable price. And that's cool. You need to be open. You need to be open to learning and to teaching. You need to be open to giving iOS developers the space to learn Scala. You need to be open to letting systems people get to grips with JavaScript. And you need to be open to letting teams have root on at least some of your servers. You cannot, like, this may be tricky in a more regulated environment, but you can still do this. You have to be more careful who you give root access on which servers, but it is possible. It is totally possible to have the payments team operate everything about the payment service. It means fewer people need access to these systems, not more. Because that team needs access to the payments code and stuff anyway. Now they're also operating the database, which is great. Nobody else needs to be able to access it anymore. To be effectively own what you build, you need to be proud of it. You can't build something and then throw it over the wall for it to become someone else's problem. You need to also emotionally own that you're doing good work with this, that this is something that works and that keeps on working. As an infrastructure engineer, it's sometimes hard because none of the features that you use I had directly anything to do with. So for me, it's a moment of pride when a feature gets shipped and I had no hand whatsoever in doing it, because that means the automation worked. It means that the infrastructure was there to support this feature without me needing to be involved in this. And that is also something that you can be proud of. And finally, this is really important as from the organizational, from the management side, you need to have trust. You need to have trust in your engineers that they are doing the right thing, that they want to do the right thing, and that they are, that everyone is doing their best at all times. If your ops people think the developers are stupid and refuse to deploy anything, and the developers think that the ops people are just lazy because they don't want to learn how to operate like the 15th database technology, then you got to work on that. But if you generally trust each other and you generally trust that everyone didn't do it intentionally or out of spite, that they just didn't know that this query would wreck the database, then you can start thinking about how can we go forward? How can we make this better in the future? How can we make it easier for an application developer not to wreck the database? Also, if the developers want a new database technology, go ahead, let them do it. Let them run it and let them operate it. And yes, it's going to fall over. It's going to break horribly. They're probably going to lose the data twice. Let the ops people go, told you so, that's okay. But work together to make it better and to improve and to go forward. And maybe the result of this is that developers say, okay, maybe this wasn't such a good idea. This is how MongoDB went out of SoundCloud again. Or maybe it's a thing of, okay, this actually works and now we're running it. Start by expanding ownership. Start by having the development team's own testing and deployment of their service. They are responsible for making sure that the service, that a change is fit to go to production, and they are responsible for getting it there. Once they are responsible for getting it there, it becomes natural to put them on call for it, to have them be the first to handle issues. They put it there in the first place. They know it best. This works really well. You don't need to throw them in at the deep end. You don't need to throw them in at the deep end. You can always have backups. Have what is now your ops team as the backup. At SoundCloud, we have the rule that if you don't know what's going on anymore and who you should be paging, you page production engineering. This is what, like, we have enough context about the whole system. We don't know about like the inner workings of half of these systems, but we know enough to be able to triage and help you triage and help you figure out who to page next. And this is, and to generally be there for you and commiserate. Sometimes that's also helpful. So now your developers are on call for the services themselves. Let them also own the provisioning of dependencies. Let them own the dependencies themselves. It becomes natural once you're on call for the service. Why am I not also on call for the database? Because when the database breaks, the service is broken, and when the service breaks the database, like, why should someone else get paid for this? This is like, once you get on this road, it feels more and more natural to have this wide this deep stack of ownership where you own everything that makes up a feature, unless it's owned by someone else. But where there isn't any magical database land where something happens. And I'm using databases here as an example because that's what works for us. We also have shared infrastructure. For us, we've put the level at basically at the deployment platform, and we've put databases in the land of owned by developers, and we put compute is owned by infrastructure. This may be very different for you. I know that many other companies that are more on AWS than we are, actually they have a completely separate AWS account for each team. Everything is isolated there. And sometimes they only talk over the public internet to each other. And that's cool. In other cases, it might be more prudent to run one large database cluster that is really well maintained and well scaled and multi-tenant, potentially because it's cheaper. So having many database clusters, the utilization isn't always great, but for us, it's worth it. So this is kind of up to you where you draw the line. But it's important to consciously draw this line and think about what do we want, what belongs to the ownership of a feature or of a system, and what doesn't. Yeah. You need some like this. There will be things that go. There will things that go wrong. There's always something that goes wrong, and you will not know ahead of time. So there will be issues and there will be outages. Some things will happen that an experienced ops team would have caught before it hits production. That's okay. These are learning experiences for everyone. But here are a bunch of things that can help you get through this phase faster and that can help you recover from these issues faster. You can, as I already said, internal moves help spread knowledge around. Changing roles and moving between teams spreads institutional knowledge and experience. A systems person in a team of software engineers will both learn and teach a whole lot. A software engineer in a systems team will be in a great position to improve the quality of the tooling and automation, both because they have the skills for it, but also because they've been the users of it. They will know where the pain points are. And they will pick up the systems knowledge along the way. There's never a problem with that. So for OnCall, Move, make sure that people on the front line can solve the most common problems. So this is where good runbooks come in, but also always make sure that they have an escalation path, that they know who they can escalate to, both about a specific service or a specific system, as well as about general issues. Like if they think it might be the network, make it clear who they can talk to about checking the network. Sometimes it is the network. It's rare, but sometimes it is the network. Perfect document. Oh yeah. So yeah, you need some documentation and tooling. They don't need to be perfect from the start, but you need to keep improving them. You can look out for opportunities to improve them. Often, when the first level on call doesn't know, couldn't figure out the solution to an issue that wasn't just like a one-off that will never happen again. Sometimes you have these, but if they couldn't figure out the solution to an issue that keeps reoccurring, we ask. They often pair with someone who is an expert in the system to fix it, and then we ask the person who was on call for it to actually write this documentation. Sometimes often with the expert, but it's easier. When you're an expert in a system, it's really easy to write documentation that only experts can use, because you can make a lot of hidden assumptions that others just don't, or hidden knowledge that others just don't share. If you let the person who couldn't figure it out write down the solution after they figured it out with you, then that means they can, the solution is at a level of detail that other first level on-call engineers can also solve. And it's going to be over detailed for you as the expert, but you as the expert don't need the runbook anyway. You know what your service is behaving like. So it's not for you. Also, if some piece of tooling isn't foolproof and fails, improve it little by little. Just tiny changes, one at a time, and it will get better over very fast. One really good vehicle to figure out what to improve are postmortems. There is a lot of literature about postmortems. I would especially implore you to read that put out by Etsy. They kind of started this modern thinking about postmortems. Postmortems are a place, so they can take different forms. In our case, we write them as written reports, and then we have a meeting where we talk about the interesting ones. Some teams or some people just do just meetings or just documentation, although the talking about it bit is very valuable to me. It's an opportunity to learn, and that's the primary thing. Postmortems are about learning what happened, learning what there is to learn. You can improve of this, and sometimes the improvement is, well, you just don't do that again. Often the improvement is, oh, but actually we can fix this tool to not let you shoot yourself in the foot this way. I'll get to an example in a bit. Sometimes you also just commiserate. Sometimes there is just a problem that you know will happen again and that you know will happen again rarely enough that you are not going to fix it, that it's like the effort of fixing it is so big that as a business you've made the decision not to address it. And then sometimes, and you still write a postmortem about it, and you still at least commiserate, and you acknowledge that it happened and that it will happen again and that you decided not to do anything about it. That is also a possibility of a postmortem. One thing that postmortems must not ever do is assigning blame. It is never about who broke it. It is especially never about why this idiot broke it. It is always about learning something, and you always have to, and this is not 100% true, there are people out there who are just not very good at their job sometimes, and eventually you fire them, but you don't do it in a postmortem. The postmortem, and this has just proven to be a very valuable assumption, is that everyone did the best that they could with the resources that they had and the knowledge that they had at the time when they did it. It's super easy in hindsight to say, well, they should have done this other thing, yes, but they didn't know, and that's why they didn't do it. Or they couldn't because the tool didn't allow them to do it, or something like that. In principle, never assume that it's the person's fault. We've had a bunch of really bad outages because of people misusing the deployment tooling that we had. So they would go and, a particularly bad example, we had a tool where you would deploy the next 10 instances, and then it would say, okay, now check the graph, press enter if everything is okay. So what did an engineer do? They pressed enter 10 times and went for lunch. And we sat there and watched the graphs go down because the new instances didn't actually come up. That's bad, that hurt. But it wasn't the engineer's fault. It was the fault of the tool for requiring them to do a stupid thing and for allowing them to do an even stupider thing. We changed the tools. We didn't fire the engineer. We changed the tools to automatically check health of new instances because that's what deploy tools should be doing. We had a bunch of these. They were all broken in different ways. So this is also where postmortems become really valuable. It wasn't just this one instance of a broken deploy tool causing an incident. And we had several of these. Every single one of these could have been attributed to human error. A human did something wrong. A human didn't pay attention. A human didn't abort it when they should have. But that's not the point. The point was that the deploy tools were broken. And we recognized the pattern because we didn't assign it to the humans. We recognized the pattern that in all of these, the deploy tool was involved. All of these may have been like human error on the surface, but underneath it was that the tool that they used, and they were even different tools, caused an issue. So we went ahead and said, okay, the tool situation is the problem, not the people. The tools are broken. So let's go and find out what the tools all do and what they should be doing, and then we consolidated onto fewer tools, and we built the missing functionality into those. So everything, since then, we have had much fewer, I can't say none, but we have had much fewer deploy-related incidents that were purely due to broken tooling. So postmortems help you identify these points, also these repeated points of small pains, like little incidents, but they keep happening. And if you write them down and you look back on a quarter of postmortems, you say, wait, this has happened like 4 times in 3 months. Something is, like, we should be doing something about this. You can also see that, oh yeah, like this thing that looked bad while we were in it, it only happens like once every 4 years. we really don't need to invest a huge amount of work into fixing that. We can invest work maybe into mitigating it. How do we get out of this faster? Say a database server crashes and it takes you down. What can you do? Maybe you can't prevent it from crashing because sometimes they do. But what can you do to get out of that? And postmortems really help you channel this, and they help spread the knowledge of that these things happen and here's what you can do. And they help, even if you didn't do it in the incident itself, you can, like people who are more experienced or who have done this before or have dealt with this before can put in their knowledge and say, next time this happens, here's what we can do better. Also, another point of being blameless and never firing an engineer for causing an incident, like never ever do that. Because if you, as a matter of policy, never ever do that, your engineers will feel safe in saying, hey, I messed this thing up, I know I broke it, I know how I broke it, we can fix it now. Than them staying mum and like pretending nothing happened, and then everyone scrambling and trying to find what the fuck is going on. It's much easier if everyone always trusts that they can say, I made a mistake, I broke this thing, let's go fix it. Let's find out what happened. And we've had lots of horrible incidents like this. No one ever got fired for any of them. So that improves the time to recovery, basically. And that's it. We have about 6 minutes for questions. The slides are up there. Also, if this sounds like an environment you would like to work in, we're hiring.